Video we are going to learn about horizontal axis wind turbine. This video explains about components, rotor, hub, nacelle, generator and controller, yaw system, tower and foundation, HAWT technological evolution, global wind capacity. Components. Rotor. Rotor mainly consists of blades and hub. Nacelle protects low speed shaft, brake gearbox, high speed shaft, generator, controller, anemometer with wind vane, yaw system, tower and foundation. This is the picture of the wind turbine. It consists of blade, rotor, pitch system, generator, controller, yaw drive, tower. Rotor. Rotor consists blade. Blade is the main part, convert free flowing wind energy to useful work. Approximately 20% of the wind turbine cost. It uses lift and drag principle. 3-blade rotor is best compared to 2 and single blade turbine. The blades rotate at 10 to 22 rpm. At 22 rpm, the tip speed exceeds 90 meter per second. Higher speed means more noise and blade erosion. Single blade HAWT reduces cost and weight of the turbine. It's rarely used due to tower shadow effects. Needs counterweights on the other side of the blade, less stability. 2-blade HAWT requires more complex design due to sustain of wind shocks, less stable, saves cost and weight of one rotor blade. 3-blade HAWT high strength, less effective to tower shadow, produces high output. Hub. In simple designs, blades are directly bolted to hub. In sophisticated designs, they are bolted to the pitch mechanism, which adjusts their angle of attack according to their wind speed. The hub is fixed to the rotor shaft, which drives the generator through a gearbox. Nacelle. Low speed shaft. The shaft from the up to the gearbox speed is typically between 40 to 400 rpm. Generator typically rotated at 1200 rpm to 1800 rpm. Brake gearbox. Gearbox increases the speed of the shaft, meet the requirement of the generator. High speed shaft. Gearbox shaft is followed by the high speed shaft connecting to the generator. Generator converts mechanical energy to electrical energy with approximate 34% of the wind turbine cost. Generate electricity through asynchronous machines that are directly connected with the electricity grid. One end attached to the wind turbine, other end connected to the electrical grid. Require cooling system to prevent overheating. Controller starts when the machine at wind speed of about 4 meter per second and shuts off the machine at about 25 meter per second. May damage wind turbine. It gets wind speed data from the anemometer and accordingly. Yaw system responsible for the orientation of the wind turbine rotor towards the wind. It is the mean of a rotable connection between nacelle and tower. The nacelle is mounted on the roller bearing and the azimuth is achieved via ability of powerful electrical drives. Yaw system consists of yaw bearing, yaw drives, yaw brake. Tower. Typically, two types of towers exist: floating towers, land-based towers. Floating towers can be seen in offshore wind farms where the towers are float on water. Land-based towers can be seen in the onshore wind farm where the towers are situated on the land. For HAWT, towers height approximate 2 to 3 times the blade length. Have been found to balance material costs of the tower against better utilization of the expensive active components. At the bottom level of the tower, there will be the setup transformers for the connection to the grid. These are the different types of land-based tower: lattice, tubular, Tilt up guide. Foundation. A very good foundation is required to support the tower and various parts of the wind turbine, which weighs in tons. The structural support component, which is approximately 15% of the wind turbine cost, includes the tower and rotor yaw mechanism. Offshore horizontal axis wind turbines HAWT at Scorby Sands Wind Farm, England. And this is onshore horizontal axis wind turbines in China.